Museum. My name is Sandy. I'm a museum assistant working here. So in a short while, I'll give you a short presentation with the magic rope here. And I will dim the light a little bit. It's alright. So here in front of you, we got our familiar planet Earth, right? And I'm going to show you about a large amount of the Earth's surface is made up of ocean. And can you guess what it will like if I drain all the water away from the ocean? And you guess what's underneath the ocean floor? Right. I'll do it in a short minute. So here I start to take out all the water from the ocean so we can have a look of what's underneath the ocean on the seafloor. And you can see. So the seafloor is actually not as flat or as level as we may have thought. And there are mid-oceanic ridge lying underneath the ocean. And here you can see it's the mid-Atlantic Ocean here. So here's the Africa, and here's the South America, and in between there's the Mid-Atlantic Ocean. And if I'm to take out water, it's actually a very long ridge, lying more than 70 kilometers long as the Mid-Oceanic Ridge. So this is where the magma comes out from between two crusts, and the two crusts move apart from each other and generate new oceanic crusts here. So you can see the Earth is actually made up of different plate, and here's one of the plate boundary. It's actually made up of different continental plate and oceanic plates. And I'll show you. Here's the plate. Wow. So this is our familiar. So as you can see, there are mainly three types of plate boundary, right? As shown is different color. And do you know what kind of plate boundary do we have on Earth? Any guess? So the first one is shown in the red color, just as I mentioned before. It's the divergent plate boundary as shown in the Mid-Atlantic Ridge. And the second type of plate boundary is the convergent plate boundary, where two plates move towards each other. And as you can see, shown by the blue color here. And one of the examples is the collision of the Indian plate to the Eurasia plate, led into the build-up of the Himalaya mountain. This animation is also shown on the first floor in the museum, which I can show you. So here was just mentioned the Indian plate moving lower to the Eurasia plate, and two plates collide with each other and led into the build-up of the Himalaya mountain. So we have talked about two types of plate boundary, right? So the third type of plate boundary is shown in the yellow line here, where is the transformed plate boundary. And this is where two plates slide horizontally to each other. And this can be one of the major area where earthquake is very common. For example, this is a layout showing the common earthquake happening in the planet Earth. And as you can see, most of them happen along the plate boundary, as you can see. And one major example is the North America, and in the California where there is the San Andreas Fault. This is where the two plates slip across horizontally to each other, and when one plate can no longer withstand the high pressure and stress, and then the stress and energy is released as a vibration of the ground. So after looking at the earthquake, we can proceed to look at some commonplace of the volcano, right? So most of the volcanoes again occur mostly along the plate boundary. More than 60% of volcanoes magmatic activity occur along the plate boundary of the Pacific Ocean, which is also known as the Ring of Fire. So here but of course there's also always an exception. So you can see this is the Hawaii Island, and this is an example of an intraplate volcanism. It happened because of a mantle hotspot in the mountain. In the mantle, and where it is a station hotspot, while the Pacific plates on top of this hotspot move very slowly to the northwest direction, and this produces a chain of volcano. So as this station hotspot, they leave the mantle and the plate moving northward. So you can imagine what happened is that here you got one volcano here, and as the plates move slowly northwards, it generates another new volcano, and the past volcano died out. So after years, millions of years, it produced a chain of volcano with different ages, and most active one is currently located here. So you can also see. So in the last slide here, we try to show you how different plates evolved to the present position over millions of years ago. So can anyone guess what is the position of different plates, different continents was when it was like 280 million years ago? Are the position still like present day? Let's say is Australia still at this position a long time ago? I'll show you a really short video showing how the different continents evolve over time. So here is a short video showing how our continent evolved over time. And as you can see, a long time ago, there's actually a big giant landmass joining together to form one supercontinent known as the Pangaea. So across the meantime, due to plate motion and driven by the mantle convection cell, you can see different continental plate drift apart to each other and evolve slowly to the present day position. So we can give a series of evidence of how this occurred. So when we first come up with this idea, we noticed the coastline of different plates, which is rather they can fit in together like a puzzle. So we start to investigate the fossil evidence, rock formation in different continents, and we found that a lot of these continents suggest that once this supercontinent do exist. And for one example, one very important example from the fossil evidence is the is we can find a kind of freshwater reptile located in different continents. And this freshwater reptile, we find that in South Africa, West Africa, and also in the South America. And it is highly unlikely that this freshwater reptile can travel all across the ocean and to land on the other continent and to reproduce. And also, if they really can do it, which is almost impossible, and we can find the fossils spreading across the ocean, right? So, but however, we only got the fossil evidence on the continental on the continents. So we come up with the idea that once these landmarks are joined together, and due to continuous plate motion, different continents drift to their present position as shown in the map today now. Is there any question from you?
Yeah. We have a quick tour of the solar system.
ใครจะมีอะไรคำถามอะไรไหม
We leave the Earth and we have a quick tour. So what's this? What's this one?
The sun.
Yes, the sun. You have just look at it through a telescope, right? Yeah.
And
So next. How about this one?
Jupiter. Venus.
Venus, correct. So Venus have a very thick layer of atmosphere. So the layer of atmosphere is very thick.
คุณหรือเปล่าเอ้ยอยู่เลยนะ
วีนัส
What the Mars.
Yes, correct. Mars, and they have a lot of volcanoes here, right? Do you see? This one is the Olympus Mount, which is the highest volcano in all the solar system. And we have a Marinus. This is the one of the largest canyon along the solar system.
Mars.
So, but these are the names. Okay.
Jupiter.
Yes, Jupiter. So there are lots of different layers of clouds, right? So if you look carefully, you can see they're in different motions. Sometimes it's eastward, sometimes it's westward. And there are so many giant weather systems here. So we have one for the Great Red Spot.
Why I can see the big red spot?
Well, I think it's this one. Great Red Spot.
No.
ไหนอยู่ไหนสิไปหาสิ
Oh no, at the back. So this one is the junior. Some white oval.
จิไปหา
But now we have more than one red spot on Jupiter. And this is Saturn. This is Saturn without a ring.
I know.
Yeah.
Yes.
Okay. Next.
Uranus.
Yes, correct. Uranus is a big plane.
Where is Iron?
But still, they still have clouds.
What's the Mercury?
Yeah, where's the Mercury?
Neptune.
Neptune. I like that. Yeah, it's still
ไวไวนะ
อันนี้มีแต่อากาศหรือว่าไง
Mercury.
This is Mercury, but I think this one is
No, it's
because
moon.
is it moon?
Mercury.
moon
Wait, we have to check.
มีสองด้านเรื่องมูนแน่ๆชัวร์เลย
moon
No, it's Mercury. This one is Mercury.
Mercury.
Mercury looks much alike with the moon, but if you compare with the moon, you will see a difference.
คือใช่
But this one is old. Nowadays we have just a new spacecraft. We orbit around Mercury. We circular orbit around Mercury, so we can take. In the past, we cannot see the other side of Mercury, but now we can. We know what this looks like already. So let's compare with the moon.
Yes,
And this
that
one is-
moon.
So you can see there's some different.
ดูตรงไหน ตรงไหน มันต่างตรงไหน
Okay, just give you some more. Quick one. So you know that not only moon is only it's the moon of our Earth, right? But we have the moons of other planets. Say for example. Do you know?
This Io.
Yes,
Io.
Io,
Yes.
the moon
Volcanic
of
planet.
volcanoes. So you see there are lots of active volcanoes. Everyone here is an active volcanoes here.
How are you?
ดวงจันทร์
Yeah,
ดวงจันทร์ของ
one of the
ดาว
moon
พ
of
ฤหัส
Jupiter.
ปีแล้ว
And there's lots more. Okay. Okay, but we have limited time, so maybe we can look at it later. But we have some display here. I will give Sandy to introduce.
We got a list of display of fluorescent minerals showing here. And what this mineral is about is that when I turn on the UV light to activate the minerals, that it causes a change of state on the electrons inside the atom of the minerals. And when
ที่เป็นคนชวนมาใช่ไหม
and when there's a change of state of electrons, it gives out an energy in the form of a wavefront, which is a visible light, like from red to purple. So in a short while, I will just turn on the UV light, and please feel free to come closer to have a look.